Alright. In this problem, a dud missile is fired straight into the air from military installation. The missile's height is given by the formula h of t equals negative 16t squared plus 400t plus 100. Question A. How high is a missile after 4.5 seconds? So how high, that's your h value. After 4.5 seconds is t. So I'm going to change my t's to capital T's. So if t is 4.5. So essentially what they want in this problem is your height after 4.5. So basically every t value I'm going to replace with 4.5. So then I'm going to use order of operations. I'm going to use exponent first before I multiply by negative 16. So 4.5 squared is 20.25. 400 times 4.5. I'll show you guys how to do it faster on your calculators. And if I multiply those values, I got negative 324. So I get after 4.5 seconds, my height is 1,576. Raise your hand if you got that. The missile is 1,576 feet after 4.5 seconds. And in my calculator, negative 16x squared plus 400x. So I know it has t's, and there's t on here, but don't do that. Just think of it as x over here. Plus 100. We talked about going through a table set. So I'm going to check this calculator second. Window. I want it to ask me and then automatically come up with the answer. The input is independent and the output is dependent. So I go to the table and I'm just going to type in 4.5 and press enter. And 1,576 is on there. Okay, so way to use your calculator. I'm going to skip the heights. So we did that question. When will the missile be 2,500 feet above the ground? So 2,500 feet above the ground is, in our formula, this part. We want the height to be at 2,500. So 2,500 equals negative 16t squared plus 400t plus 100. And then here, I'm just going and solving. Subtracting 2,500. I get 0 equals negative 16t squared plus 400t minus 2,400. I'm going to factor out a negative 16. I get t squared minus 25t plus 150. Class, do you really want to use quadratic formula for that? I would not. Would it be easier to use quadratic formula for this one? Mm-hmm. Yeah, it would be, but I want to take a shot at what?
Factoring.
Factoring. So again, these numbers are a little bit larger, so you can do a strategy of writing out all the factors. 150 times 1, 2 times 75, 3 times 50, 5 times 30. What else? 6 times 25? 15 and 10. Which one, class? Whether I add or subtract, it'll equal negative 25. I did think about 30 and 50 at first, but it's going to be 15 and 10. The reason why is A times C is 150, and your B value is negative 25. If I put in here 15 and 10, and they're both negative, if I add those together, they'll equal negative 25, but they'll multiply to be positive 150. So I have 0 equals negative 16 times t minus 15, t minus 10, and then here I can just use a zero product rule. Negative 16 equals 0, t minus 15 equals 0, t minus 10 equals 0. Class, does negative 16 equal 0? That's a no solution. Here t equals 15 and t equals 10. When will the missile be above the ground? Will be 2,500 feet above the ground between 10 and 15 seconds. Let's draw a picture. This is my straight edge. Everyone say label. I'm going to penalize you for not labeling. Time measured in seconds. Height measured in feet. Put your finger on the y-intercept. Show your partner. Give him a head nod. Yes, no. Your y-intercept is 100. So your military installation is actually 100 feet above the ground. You're on, the missile is being launched. The missile is actually being launched from 100 feet. Does that make sense? Because if you put in time 0, that becomes 0, that becomes 0, and you're at 100. Okay? So in that problem, when it says 2,500 feet, you have to think, I'm just going to put it right here, 2,500. Then what's happening is you're really looking for where it's crossing at this point, which we found to be 10, and this one at 15. Here's an extension question that could be asked. How long is the missile in the air above 2,500 feet? Well, between 10 and 15 seconds, if you subtract the two, it's how many? 5. It's above 2,500 feet for 5 seconds. In that previous problem, we kind of said after 4.5 seconds, so here's 10 seconds, it's probably just like right here, that's like 1,576 feet. And the last question, when will the missile be 100 feet above the ground? So that'll be in my function, so I'm going to write the original problem. H of t equals negative 16 t squared plus 400 t plus 100. And then when will it be 100 feet? That goes here. So I have 100 equals negative 16 t squared plus 400 t plus 100. You should have been paying attention. Look, you didn't have to use a quadratic formula, because if I subtract 100, I get 0 equals negative 16t squared plus 400t. Okay, pay attention. I don't have a c value. I can factor out negative 16t. And if I do that, that gives me t minus 25. And then each of these I can set equal to 0. So this becomes t equals 25. This one you divide both sides by negative 16. And t equals 0. So when will the missile be above 100 feet above the ground? For a very long time, isn't it? Even at t equals 0. So between 0 and 25 seconds. So visual for that problem, 0 and 25 on the picture. Well, here's 0. We didn't mark 25. I guess our picture's not really drawn to scale, but what's happening is it just wants it at 100 feet. So basically the top of the building. So basically on that last part, it's in the air for 25 seconds. Because they want to know how long is it above this 100 feet line. Let me show you guys one more thing. Let's see if this works. Calculator. Let's see, turn the brightness. If you have it into y equals, and this is your graph, it won't show up, right? See nothing, okay? But with this picture, it kind of tells us some clues. Oops, that's 25. I'm going to change my window, and I'm going to make it from 0 to about 26. So x max 26. And I'm going to change the x minimum to about -1. So I'm at the window. X scale means what do you want it to count by? So I'll count by 5s. Y minimum is over here. Try that again. Sorry, you guys can see the picture. I'm changing my window. X minimum is like right here. I'm trying to focus just on quadrant 1. And I'm trying to get a snapshot of the whole graph. This is 25, so I'm just going to go one more than 25. I got 26. X scale I counted by 5, so my graph you just see tick marks every 5. Y minimum, that's your height. I'll probably start at -1 because I want to see the x-axis. And then I kind of want something like way up here, right? So that might be like, I don't know, 4,000. See if it works. And I'll count by, I don't know, 500. So basically what I'm doing is I'm manually changing the window to match where my graph is. Let's see if it works. Ready? Ready, set, go. Oh, 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 there goes the rocket. Okay. Now watch what you can do with the other problems. 2,500. See that? We marked it with the pink line. You can actually go to y equals and just put in 2,500. You're not impressed, are you? But then you can do like calculate. Everyone say second trace. And I want to find the intersection. So there's the blue line, the red line. There's my guess. Look! The answer showed up on my calculator! It told me the answer. Look, at 10 seconds, it's 2,500 feet. When will the missile be 2,500 feet? 10 seconds. This thing's amazing! It showed me all the answers. You can check it. Don't write everything on your calculator on your piece of paper. I'll give the A to the calculator, not you. So show me the work, and you have hints with your calculator.